If you are finding it difficult understanding limits of a function, you've come to the right video. In today's video, I'll be giving you an easier explanation to understanding limits of a function. Now let's start. We have about 5 methods of solving limits of a function. The first one we have is direct substitution, factorization, rationalization, limits at infinity, and the L'Hopital's rule. So we are going to be solving them step by step. In direct substitution, what we do is that we just substitute the value of x into this function and we get our answer. So we have solution. So putting x here, we have 2 into 2 plus 1. So we have 4 plus 1. That's 5. So this is how to solve for direct substitution. Now let's take another example. We can use direct substitution to solve this. Now what we just do, we substitute the value of x as 3. So we have 3 plus 3 over 3 plus 1. So that is going to give us 3 plus 3 is 6 over 3 plus 1 is 4. So this is 3 over 2. So this is our answer. We have the second method. This is factorization method. Now we use factorization method for specific kind of questions. It's not all questions that we use factorization method. So when do we use factorization method? When we substitute the value of x and we get 0 over zeros. That means the numerator is 0 and the denominator is 0. So in a case where we have this, we are going to use factorization method. So let's check if we are meant to use factorization method here. Now substituting the value of x as 2. So we have 2 square minus 4 all over 2 minus 2. So 2 square is 4 minus 4 all over 2 minus 2. So 4 minus 4 is 0 and 2 minus 2 is 0. So in a case like this, we are going to use factorization method. So this value we got is not the limit of the function. For us to factorize x squared minus 4, we have to use difference of two squares. Now difference of two squares, when we have something like a squared minus b squared. So in this case, is x squared minus 4, which is the same as x squared minus 2 squared. So when we have something like this, we are going to be having a plus b and a minus b. So using difference of two squares in this, we are going to be having x plus 2 and x minus 2. So let's put it here. Now we'll be having limit of x approaching 2, x plus 2 and x minus 2 all over x minus 2. Now what is going to happen? This will cancel this. So we'll now be having limits of x approaching 2, x plus 2. Now we have this. We can now substitute the value of x as 2. So putting x as 2, we have 2 plus 2, which is 4. So this answer, this is the value of the limit of this function. So now we have another example. Let's substitute first the value of x to be minus 2 and check if it will give us 0 over 0. That is, the numerator will be 0 and the denominator is 0. So substituting the value of x as minus 2, we have minus 2 all squared plus 2 into minus 2 all over 2 plus 2. So minus 2 all squared is 4. 4 minus 4. Minus 2 times minus 2 is minus 4. So all over 2. Here we have minus 2. So that is minus 2 plus 2. So what this is going to give us is 0 over 0. So this is not the value of the limit. So we are going to be using factorization method to solve. Factorizing this, we'll be having limit of x approaching 2. Now, when we factorize this, we'll be having x into x plus 2 all over x plus 2. Now, this will cancel this. We'll be left with only x. So, we have limits of x approaching 2, x. So, now we can substitute the value of x as 2 here. We'll be having 2. So this is our limit, the limit of the function. Now let's go to the next method of solving limits, which is rationalization method. In the case where we have a root, we are going to use the rationalization method to solve the limit. Now if you look here, we have square root of x. So we are going to use rationalization method to solve this. Now how do we solve using rationalization method? What we do is that we find the conjugate of the function that has the roots. So this function with the roots, we find the conjugate of this. So the conjugate of this is changing the sign of the function. So we change this sign. The conjugate is going to be square root of x plus 2. So this is the conjugate. So what we will now do is that we multiply the numerator and the denominator by this conjugate. So this is going to give us limit of x approaching 4. We have square root of x minus 2 times square root of x plus 2 all over x minus 4 times square root of x plus 2. Now we simplify. Limit of x approaching 4. Now square root of, we multiply this and this. So square root of x times square root of x, we have x. Square root of x times 2, we have plus 2 square root of x. Minus 2 times square root of x, we have minus 2 square root of x. Minus 2 times plus 2, we have minus 4 all over x minus 4 square root of x plus 2. Now if you look here, we didn't simplify this further because what we want to do is that we want to cancel one of these, because when we finish solving this one of these values are going to cancel out. So you see what we have now. We have limit of x approaching 4. So plus 2 square root of x minus 2 square root of x is 0. So they will cancel out. So we have x minus 4 all over x minus 4 square root of x plus 2. Now this is going to cancel this. So we will be left with limit of x approaching 4, 1 over square root of x plus 2. So this is what we have now. Now, and now substitute the value of x as 4. So we have 1 over square root of 4 plus 2. So this is 1 over square root of 4 is 2. 2 plus 2. So we have 1 over 4. So this is our answer. So this is how to solve using rationalization method. In case where we have a equation like this, a function like this, remember, since it has roots, we are going to use rationalization method. So we have limits of x approaching 1. So x minus 1 all over square root of x minus 1. So for us to solve this, we are going to find the conjugate of the function with the roots. So this is square root of x minus 1. The conjugate is going to be square root of x plus 1. So we multiply by square root of x plus 1. Square root of x plus 1. So now we have limit of x approaching 1. X minus 1 and square root of x plus 1. The only part in the function that we simplify is the part which we got the conjugate from. So this is the part which we got the conjugate from. So we have square root of x times square root of x, we have x. Square root of x times 1, we have square root of x. Minus 1 times square root of x, we have minus square root of x. Minus 1 times 1, we have minus 1. So it's going to be limit of x approaching 1, x minus 1, square root of x plus 1 all over. Now square root of x minus square root of x is going to cancel out. So we'll have x minus 1. Now this will cancel this. So this is limit of x approaching 1. Now we'll be having square root of x plus 1. So now we can now substitute our value of x as 1. So we have square root of 1 plus 1, which is square root of 1 is 1 plus 1, which is 2. So this is our answer for the equation. In a case where we have the limit of the function is that in a case where we have x is approaching infinity, that is when we use limit of a function at infinity. So when solving limit of a function at infinity, what we have to do is that we have to divide everything by the highest power of x in the denominator. So we divide everything by x. So we have x approaching infinity. So this is 2x over x plus 1 over x all over x over x. So we divide everything by x. So this will cancel this will cancel this. So this is limit of x approaching infinity, 2 plus 1 over x all over 1. So this is limit of x approaching infinity, 2 plus 1 over x. So now we substitute the value of x as infinity. So we have 2 plus 1 over infinity. Now, if we have something divided by infinity, let's say we have 5 over infinity, the answer is 0. So here we have 1 over infinity. So we have 2 plus 0. So our answer is 2. So let's say we have a equation like this. We have x is approaching infinity. So what we have to do is that we have to divide everything in the function by the highest power of x in the denominator. So x here is raised to power 1. So we divide everything by x, limit of x approaching infinity. So we have x squared over x plus 1 over x all over x over x. So this will cancel this will cancel this. So we'll be having limits of x approaching infinity, x plus 1 over x all over 1. So this is limit of x approaching infinity, x plus 1 over x. Now we substitute the value of x as infinity. So we have infinity plus 1 over infinity. So this is infinity plus 1 over infinity is 0. So we have infinity. So this is our answer. Now we go to L'Hopital's rule. We use the L'Hopital's rule when we have 0 over 0 and infinity over infinity, when we have substituted out the value of x. So let's check for this. Now, if we put x to be 2, we have 2 square over 4 all over 2 minus 2. And this will give us 0 over 0. So in this case, we can use L'Hopital's rule. In this case, we use factorization. We can also use L'Hopital's rule to solve this function. So in L'Hopital's rule, what we do is that we differentiate the function. So how do we differentiate this function? When we differentiate this, we are going to be having, when we differentiate this, we'll be having 2x. And when we differentiate this constant, we'll be having 0. So no need of adding it. So when we differentiate x, we'll be having 1. And when we differentiate minus 2, we'll be having 0. So we have 2x. So this is going to be lim x approaching to 2x. So substituting the value of x as 2, we have 2 into 2, which is 4. So this is how we solve using L'Hopital's rule. We differentiate the function and substitute our value.